I will be teaching astronomy next year as a whole year course, which means it will be presented in alpha period on both the fall semester and the second semester. You will be able to take it as a full year course, and that's very advisable, or you'll be able to take it as part 1 or as part 2 astronomy. However, if you come to part 2 astronomy, it is very, very necessary that you know and understand your algebra too. In astronomy, we have 73% dark energy, 23% dark matter, and since nobody knows what this really is, that means that we don't understand about 96% of what goes on in the universe, which means we have really information only about this little bit of matter in the universe. So what we'll do, we will be able to, in this course, you actually are learning to think a bit differently. And if you will meet students from the past who took astronomy, they'll tell you that you do think differently. And also you will apply your physics from freshman, and if you take it concurrently, you can do that. And it will help you to also strengthen your mathematical skills, because now you're actually applying your math to something else that is another science. We're using acceptable college-bound books that have been checked by other scientists in colleges. And we will examine the following. We're examining the universe, of course. We're examining stellar evolution, planetary system, and galaxy and cosmology. We are going to be using telescopes, and hopefully you'll learn to use computerized telescopes. We are also learning from other journals, current journals, about space telescopes that are right now the largest and the best, such as James Webb Telescope. We are going to learn about light, because this is one of the only ways that we actually get information from stars. Okay? We get it through light and light waves and photons. So we will learn about the solar system. We'll learn spectroscopy, and actually you already probably learned some spectroscopy in chemistry. And you will learn about radio, visual, and other waves. You will learn about star evolution, birth, and death. You will learn about nebulas, how stars form, about our own star, which is actually a simple middle-of-the-range star, and of course, the energy that stars produce through nuclear fusion. You will learn about red giants and look at our sun versus a red giant. Very, not that big, our sun. We'll learn how to measure stars that are nearby. Near is all relative. And very, very far away from us. And we will learn about supernova and about black holes, which you're very interested in. We'll learn about microgravity, which I just came back from a NASA experience and had a fantastic microgravity experience in an aircraft from Houston, Texas. And this is because students here created the experiment. So why are we able to create an experiment like that and take it to NASA, to Houston? Is because we are part of a NASA Explorer Schools, which gives us all sorts of ability to communicate with NASA in ways which other schools are not able. They helped us design an experiment, and we actually can communicate with them on an ongoing basis through DLN session, distance learning sessions. And we also go through sky gazing if weather permits. So these are fantastic opportunities that, if you have them on your resumes, can help you get into better universities. So I hope to see you in 2009, 2010. Have a fantastic time. Bye.